Hello, my name is Bob D. Hilster, and I am your particle model guru. I'm here today to talk about the particle model, and the question is it real? Can I actually prove that this is, in a sense, absolutely true? When you're trying to prove something, a similar example of proving things that happens in the courtroom all the time. You need evidence to prove someone is innocent or guilty in a courtroom. Direct evidence, eyewitnesses are great. Actual videos, you can see what the people did or didn't do. You can get signed documents, or whatever, lots of different things you can propose, which I would call direct evidence. It's hard to refute. You can easily prove that, well, yeah, the guy was there, or not, or was somebody else. Maybe not. Sometimes these videos are not that clear, but that is direct evidence. You can have what I'm calling indirect evidence, or in the courtroom they call it circumstantial evidence. This is where the lawyers provide motive, opportunity, and means. And sometimes, even though you don't have any direct evidence, the circumstantial evidence can be so compelling that the jury can come up with a conclusion that someone is innocent or guilty. Circumstantial evidence, if there's enough of it, can be very compelling to make you think, wow, maybe this guy's innocent, or maybe he's guilty, whatever the case may be. Well, in science, we have similar situations. To prove something in science, you need to provide direct evidence. And then I imply this idea that there is indirect evidence. And then there's evidence from your model. Once you get to a model and you suggest that this is a way it might be, that model itself can tell you something. So, proof or predictions, or both, or conclusions. So looking more closely at direct evidence and indirect evidence and evidence from your model, direct evidence is easy to prove. What I'm really saying is, as a scientist, if I can sense this with my senses, I can see it, I can hear it, I can feel it, I can smell it, taste it, whatever else, I can feel gravity, or I can use instruments that I'm convinced I know what they're doing. You've got to be convinced that what is that instrument really doing? What is it detecting? And once you understand what it is and are convinced, you can use that instrument to help prove. Here's an example. Motion is direct evidence of motion. The apple falls towards the center of the earth, the moon orbits, the planets orbit. That's motion. We have direct evidence of motion, and it's easy to prove. I can prove to you probably quite easily that the sky is blue, because people see it. We have instruments that can detect the frequency of the blue. Direct evidence, easy to prove. Indirect evidence, however, is not so easy to prove. It must be tested. For example, motion is indirect evidence of Newtonian gravity. It's direct evidence of motion, but it's indirect evidence of gravity. And that's what Newton came up with. He said, I think, based on the apple, the moon, and the planets, that there is a force called gravity. And he did that by using motion as evidence, but that's indirect evidence. He had no direct evidence of gravity. He clearly stayed away from proposing any idea of what gravity could be. He was being very cautious. Now, in the particle model, we're using the motion of the apple and the moon and the planets to have a similar solution for gravity, but we're proposing something. I'm stepping out there, taking a risk and saying, hey, there's a particle which we call G1, which is responsible for Newtonian gravity. Further, I did a video on titled The Two Gravities. I looked at the bending of light in a prism. That's motion. Light is moving. It's changing direction. The bending of light is indirect evidence of something, and I claimed in that video that it's evidence of a second gravity, which we call G2 gravity. I'm using indirect evidence of using motion of the bending of light to do that. Now that I build a model, I got three particles, the nucleon, the G1 particle, and the G2 particle, and I'm making some assumptions here. The assumption of there's a G1, G2, there's no charge, it's all mechanical, it's all push. All these assumptions put together. So I have these assumptions, and then I can try to make a prediction about what's going to happen, or show you a solution to the double slit based on that. And so you can make predictions from your model. So your model suggests that gravity is caused by, I'm saying it's a particle, you might say something else, but this is very difficult to prove, very difficult. So considering the direct evidence of gravity, there is no direct evidence of what gravity is. No direct evidence that gravity is caused by a particle. There is no direct evidence that gravity is caused by a wave. No direct evidence that gravity is caused by space-time bending. And then there's ether, and there's a crystal structure of the space. There was even an electrostatic model for gravity. No direct evidence. So with no direct evidence, without direct evidence, bad sentence, there can be no absolute proof that gravity is caused by a particle or anything else. Therefore, I cannot prove in an absolute sense it's real. People say, well, prove it to me. Well, they're looking for absolute proof. Well, I'm sorry. It's not there. I'm not claiming I can do that. Other people should avoid that as well. Now, even though there's only indirect evidence of gravity, that is, motion of the apple, moon, and the planets, Newton's suggestion that there's a force called gravity has been accepted for over 350 years, mid-1600s. It takes time, it takes experiments and calculations to make this believable. They believed it right away because they were all looking for proof that 1 over r squared really was a gravitational, a mathematical statement that described how gravity worked. And Newton claims he proved it using his equation. It takes time. There's a lot of work to do on a particle model. Dave and I have only touched the surface. We've only skimmed across the top. A lot of work to do. A waste of time. So it's very hard to prove my model right. I can't do it. It's even harder to prove your model or someone else's model wrong. People are doing this all over the place, trying to prove other people's model wrong. To me, it's a waste of time. It's a waste of your time to prove any theory wrong. You can ask questions in hope of getting me to reconsider a point of view. You may make a comment to give me some information that might help me, or you're hoping would make me back down and say, oh yeah, well, my model's not so good then, is it? So you can listen. You can do that. You can help me, or you could try to shoot me down. But if I had spent time trying to prove relativity wrong or anything else wrong, I wouldn't have done any of this work. None of it. You got to pick what you having said that I haven't done that, I did write one paper. One paper and made a presentation on special relativity. The title of the paper is there in red. Special relativity is not needed. You can find it on the link. And there's a video of it. And I'm proud to say, though, that video is not part of this YouTube series, but it is out there, and the last I saw it had over 700 views. Quite impressive in a way, at least for me. I did spend that time, and in the video I told the people, I said, look, this is my one paper, this is my one shot. You will not hear from me again because it's a waste of time. My choice, my advice to you is make up your own model or choose one that you like and then get right in there and work on it. We need people working on alternate models to mainstream because, yeah, mainstream is pretty well screwed up. Just listen to David. He's out there telling you all about that. Okay, so with no direct evidence, I cannot prove that it is real. However, with this model, over time, I worked 10 years on the model of gravity alone before I started on the rest. With this model, I've developed an equation for gravity, which I proved to myself that it is a better equation than other equations. And yes, I mean better than Newton's equation. But many will not agree, and I understand that. It's no problem. It's still my opinion, and I've done calculations over a 10-year period, and I can show you the results. I haven't done that through the video. That gets into a lot of detail and takes time. So I'm just covering gravity at a kind of a high level. Because there is no direct evidence of gravity, all options are on the table. As long as there's no, I'm repeating, all options are on the table. As a scientist, I can't just shut everything off. I can't refuse to listen in a sense. I must consider all of them and watch for clues that will help my model. Or finally be convinced that some other model is better than what I'm working on. All options are on the table, even relativity, and as much as I disagree with it, I have to say that, otherwise I'm not a scientist. I'm a follower of a model, and I believe in the model in almost a religious sense, and don't tell me about anything else. That's not science. So all options are on the table. So what keeps me going? The particle model that Dave and I are working on seems to work very well. Every time I apply it to something new or go into it a little more deeply, it's not always easy to think it through, but it seems to work very well. So Dave and I ask ourselves, if it's not real, why does it work so well? That gets us to the point where we want to say, yeah, really, yeah, guys, hey, it is real. No, we can't do that. But it sure is tempting because it works, in our case, in our opinion, works very well. My name is Bobby Hilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention.